third time doing it, the recording's to be
Okay.
finished.
So we're going to talk about vectors today. Now, if you've ever done any physics, you've probably heard a little bit about vectors.
Victors!
Um,
But it's not Victor.
for the AP test, you actually don't need a whole lot of details. We're not going to go into a whole lot of detail about what a vector means. But basically, it's another way to write a parametric function.
Mm-hmm.
We're going to use our vectors associated with a parametric function to find velocity vectors, acceleration vectors, and speed.
No jerks?
No jerks. And do not ask about the jerking vector form as far as I know.
You're a jerk.
Now, physics-wise, they usually write vectors a little bit differently. They'll either write it with little arrows on either side instead of parentheses, or I believe they sometimes write it xi plus yk. That one I'm not as sure on. But in calculus, they basically just write it like a point. Because all a vector is going from the origin to a particular point, but instead of having y in terms of x, it's x in terms of t and y in terms of t. So the position vector would be the functions you're given as a point, x of t comma y of t. That is considered the position vector for the parametric function x of t equal to whatever x of t equals, y of t equal to whatever y of t equals. So if that's our position vector, what do you think we're going to do to find our velocity vector? Take the derivative. Derivative of position is velocity. So the velocity vector would just be x prime of t, comma, y prime of t. So what do you think we're going to do to find acceleration? Take the second derivative. Now speed, we do need to get a little more complicated with. Speed, what do you think it's going to be based off of, though? Which of these? Velocity. What's the only difference between speed and velocity? Velocity can be negative. So velocity implies a direction. You're either moving forwards or backwards. Speed is just all about how fast are you going. It doesn't care about direction. So graphically, if I were to say, I'm going to pick a random point. Let's say this point is x prime of t, comma, y prime of t. Well, to get to that point in the x direction, we go from the origin. So this is actually the x prime of t distance here of t. And to get to the y value, we go up from there. So the y distance is actually y prime of t. So vector-wise, the vector is saying go from the origin to the point. Well, if we know this bottom distance and we know this right distance, how are we going to find the black distance? Distance formula, close. What is the distance formula based off of? Pythagorean theorem. If I do x prime of t squared, y prime of t squared, it would give me the distance from the origin to that value. So speed is the square root of x prime of t squared plus y prime of t squared. Which should look familiar. What does that look like? Okay, that looks like the arc length formula. What's the only difference between this and arc length? When we were doing arc length in terms of x, it was 1 plus x prime or y prime squared. This one, you did one on your warm up. What else did you have to do on your warm up on part B? Integrate.
Oh, that's what it is. Integrate.
And what do we get when we integrate a speed? When we integrate a velocity, we get a position. So this is speed. Displacement is just the integral of this.
Oh my goodness.
This time we would need a place to start and finish. So if we integrate speed, we get displacement, we get a distance from where we started to where we finished. We also may need to find position and total distance traveled, which we kind of practiced last time with parametrics. Howdy.
May I have some sugar?
Yes?
Do
Okay.
I have to just give you like a chart?
So,
Yeah.
how do we find position given velocity? We reviewed this also again really recently. If I'm given x prime of t and y prime of t, this is what I'm given. How am I going to find velocity? I think I'm going to create a little more space. Sorry, how am I going to find position?
Oh, you integrate.
You integrate.
What?
Okay. Now, with integration, though, we need more information. We need an initial value.
Oh.
So, if we have this, and we're also given an initial value, then to find our final value, we would do our initial plus the integral from our initial to our final of x prime of t. Sorry, I started writing t instead of prime. So from initial to final of x prime of t. That would give me my x coordinate. How am I going to find my y coordinate?
Same thing.
Same thing. So initial plus initial to final of y prime of t dt. And we did a unit on this, just not with vector forms. We did it with normal functions. And then our last thing, how do we find total distance traveled?
The absolute value.
Absolute value of velocity. So if I want to find total distance traveled in the x direction only, I would do just the x piece from a start to a finish. And if I want to find total distance in the y direction only, absolute value of the y piece. So most of this we've seen before, just not in vector format. And then honestly, finding a velocity vector and an acceleration vector from a position vector, not that hard. You're just taking the derivative of two things instead of one thing.
Yes, earlier, that's what I guess.
Oh.
Explains everything. I was thinking chocolate Coke. It was a big Friday, big all
Yeah.
that stuff.
Right.
I wasn't finished writing that total distance geography.
Sorry.
That's why.
Oh, you're just skipping this. Not me. Sorry, everybody.
So let's do an example in 1 second. I'm gonna let people finish writing stuff down.
Should we go to the friends? So the guy was like,
And I computed it.
you don't have to speak in Chinese or you have to reply in Chinese. So he's like, why are you reading Chinese?
Oh, is that an I? Oh, just kidding. That's the absolute value. We're good.
The rest of them, they were translators. He's like,
Well, you're kidding. Keep looking
just
for
like
it.
hose.
Your heart gives out.
Okay, let's suppose x of t is 2t to the third plus 3, and y of t is 4t squared minus 3. And let's say A, I want to find the velocity vector at t equals 3. B, I want to find the acceleration vector when the particle is at rest. So position-wise, what do we usually use to represent position? Because velocity, we usually use v of t. What do we usually use to represent position? S of t or x of t. That's- So since we already have an x of t, let's use s of t. What would our position vector be? So what should we write for our position vector? Look back in your notes and see what we wrote down for position vector.
Just what it is.
Just what they've given us, just in a coordinate form. Really wasn't trying to trick you. 2t cubed plus 3, comma, 4t squared minus 3. It's literally just what they gave you. If they gave you the position, they gave you x of t and not like dx dt. They gave us position, so there's our position vector. How are we going to use that to find our velocity vector? Take the derivative, and these ones are pretty easy to take the derivative of.
Yeah.
No tricky rules here, just straight up power rule.
She's either telling the truth or lying to us.
Ben, what's our derivative of the first piece?
60 to the second.
6t to the second. And what happened to the plus 3?
It
It's
became 0.
gone.
Became 0. Melinda, what's the derivative of our second part? 8t.
See how fast she did that? She's really good.
So there's our velocity vector, but what did part A ask us to find?
T equals 3.
Velocity vector at t equals 3. So what do we then have to do to find our velocity vector at t equals 3? Plug in 3. Velocity vector, so this is all part A. Velocity at 3 would be 6 times 3 squared, 8 times 3. 6 times 9 is 54. Thank you. 8 times 3 is 24.
I'm sure you don't have that.
So part B, we do have to do a little more interpreting. Part A, very straightforward. Find the velocity vector. Part B, it says find the acceleration vector when the particle is at rest. What do we mean by the particle being at rest?
It means it's not moving.
It's not moving,
Which
so,
means there's no acceleration.
which means there's no velocity.
Velocity.
Okay? So we want to know where the velocity is 0, but we do have two directions. We have the x direction and the y direction. We need both directions to be 0 at the same moment in time, or else the particle is never technically at rest. So we need to know, well,
You did not give yourself enough room?
I did not. We need to know when the x derivative is 0. Man,
That's T.
back. I like to do 6t squared. We want to know when that's 0, and we want to know when the y piece is 0. I'm going to,
I feel like I wrote B twice.
sorry. Okay. I agree. So, once again, these are pretty straightforward. What would t equal for our first one? 0. What would t equal for our second one? 0. So we do have a spot where our particle is at rest because they both, the horizontal and vertical movement is stopped. And that is 0. If I had more than one option, if I had like 6t squared minus 6t, I'd get a second value, like t equals 6. This is just pretend. Well, t equals 6 would not be where the entire particle was at rest. It would just be one direction is at rest. So if we do have a spot where the particle is at rest, that's what we will plug into the acceleration vector. So how do we find acceleration vector? Take the derivative again. We get 12t, comma 8. Times t, or 12 times 0, if we find a of 0, we get the acceleration vector of 0, comma 8. Which means in the y direction, our particle is always accelerating because it didn't have a time value to plug in. No matter what the time is, our particle is always accelerating. Okay, so I want you guys to try one. They ask things a little bit differently. We're not doing the exact same thing. We still are going to find the velocity vector, but I ask when the particle's vertical position is 12. How are we going to find the time when the vertical position is 12? Set what equal to 12? He's right that we need to y of t. It says when the particle's vertical position. The formula that represents the vertical position is the y of t value. So we want to know when y of t is 12. And then we're going to find our velocity vector. And then what is the speed of the particle at that time? We're going to have to use our formula that we wrote earlier for speed. Sorry, y of t should have had t's only, not x's, so I just switched to that. That's why it magically changed from x to t.
Oh. So on the speed, you just put
It proves how thirsty she
your
is.
answers into.
Into the formula for speed. So we had to
Seriously killed.
find our t values by setting y of t equal to 12.
Did it.
What did you guys get for our t values?
3.42069 and 1.754.
Yep, that's what I got.
We do want to use 5 decimal places because we've got to plug it back in. At least 5 will counteract some of the error that goes on when you approximate. Then we had to find our velocity vector by taking the derivative. So we'd get derivative of sine is cosine.
Last little bag things in front of your desk?
Derivative
Those
of
aren't mine.
the other piece. We can't see.
Sorry.
We'd plug in each of our values to find our specific velocity vectors. And then after we get our specific velocity vectors, how are we going to find the speed? Plug it into the speed formula. So square root of
15.524 squared plus 0.9613 squared and it equals 15.5538.
and then there would be a second one.
And it was just
Because we had to do both.
15.5252.
So it's pretty close to what we had.
So if it asks it like that, then we have to give both of them.
Yes. Yep. And probably on the AP test it would never have that kind of thing going on. Just
But it does.
yeah, do both. Unless it would probably limit you and say on the interval 0 to 5 or whatever, and then you'd only pick the positive t value.
Are you Taker and Kate?
Yes. I do want to point out on total distance traveled. We talked about how to find individual total distance traveled. How would we find total distance traveled for the entire thing? Total distance traveled would still be our arc length.
Take the
Oh,
square root.
right.
Yes, because it's
So if it's just one of them,
Yeah.
then you do one of those. But if it just says
total
take it
distance.
of the whole thing, then you just do the arc thing.
Yes.
Oh, okay.
Now, there's a lot of different ways I can ask you questions on this. We'd be doing examples all day long, trying to cover all the different ways that I could ask you things. You know, I can ask you to find a tangent line. I can ask you to find position from velocity. There's so many different ways. So I just want to get started on the assignment so we can address those individually for things that are confusing to you for the way it's asked. And today we're just using a worksheet, not a book assignment.
Still no figures.
Just pretend that it's one page and it's not both sides. You just pick one side. And
You probably will want to write your work on a separate sheet of paper.
No, you have to.
That is not what I want.
That was the whole point of the worksheet, so we don't